All right, now this is a fun one. So now we get to do a little bit more complicated. I like these because they're like a little puzzle, and I like puzzles. So here's what we're given. So in this example, we're told that we want to find the exact value of sine of u plus v, right? And we're given this information about sine and cosine. So we're told that sine u is equal to 4/5, where u is between 0 and pi over 2. So that means it's in the first quadrant. So u is in the first quadrant. And then cosine v is -12/13, where the angle is located in the second quadrant, right? So from pi over 2 to pi. Okay? So, and so we're going to use this information to help us here. Now, so how do we do this? Well, we're going to use the information to figure out what u and v are. Okay? And we're going to use the ratios. In fact, in this case here, we're going to try to work a little differently because we're going to use the information here to get us the angles. Okay? So first of all, let's write out the form for this. So sine, we'll start with, so sine of u plus v, right? How do we do that? Well, it's going to equal sine u cosine v plus sine v cosine u, right? Now, all we do is fill in the values, right? So sine u is 4/5. Cosine v is -12/13. Now, what's sine v? Okay, so look at so there's a couple ways you could do this. You could just use the Pythagorean theorem, or you could recognize that these are special triangles. Okay? Think of the 4/5, so this is sine across, right? Sine u. 4/5, so this is actually part of a 3-4-5 triangle. Okay? And this one here, 12 and 13, the ratio, right? 13 and 12, this is part of a 5-12-13 triangle. Okay? But you could use the Pythagorean theorem to prove it, right? So if we look at a 4/5, the first triangle, 4/5, sine u, we're in the first quadrant, right? So let's draw it in the first quadrant here. Okay, so it's going to look like this. And it's sine, so it's 4/5, right? So if we look at the Pythagorean theorem, so we get x squared plus 4 squared equals 5 squared. And so x squared plus 16 equals 25. And x squared then equals 9. And of course, we get x equals plus or minus the square root of 9, which is 3. And since we know that it's in the first quadrant, x has to be positive, and so we get 30. And so we can do the same thing for the other one and show that it holds. Okay? So you can either recognize that it has one of those special triangles, those the relationships between among the sides, or just use the Pythagorean theorem and to get your answer. Sometimes it's not a special triangle and you're going to have to use the Pythagorean theorem. But in this case, we know what it is. So sine v is going to be what? Sine v, so sine v is going to be, well, cosine is negative, right? We're in the We're in the second quadrant, so but sine is going to be positive. So this is going to be positive 5 over 13. And then cosine u, again, this is in the first quadrant. U is in the first quadrant. Cosine is positive in the first quadrant. Okay? And so cosine is going to be 3 over 5. Okay, now, guess what? Now we just simplify to get the answer. Okay. How do we want to do this? Let's factor out the fifths, right? So we're going to factor out, oh, we can't do that. Well, it looks like we're going to have to get a common denominator here. Oh no, I'm not thinking. Sorry about that. We're multiplying. We're not adding right now. So we're going to multiply first. So this is going to give us negative 48 over 65 plus 15 over 65. And now we can subtract it. Or add, depending on how you want to look at it. And so this is going to be negative 33 over 65. And that's our answer. All right, not bad. Have a great day.